Alright, so now that we got this amazing formula that tells you everything about the coefficients, we're going to get to work and actually do an actual turning of a function into a polynomial using our excellent formula here. This is incredibly important. This tells you everything about the polynomial. I told you before, the key is the DNA for the entire polynomial is contained in the coefficients. And here, my friends, we've got a recipe for all the coefficients. That means we've got everything, right? Stop me if I'm lying. Alright, so let's get to work here. Then we actually do it. Let's do it for, I think I want to do it for a super famous function, cosine. It's going to go like this. We're going to pick a starting point, 0. Really, you could pick anything where the function's good. Don't pick asymptotes or things where it's discontinuous. Things will go crazy. We're going to pick this point. We're going to find the best fitting line there that at least matches the value. Then we're going to try to match the derivative. We'll try to match the second derivative by finding the best fitting parabola. We'll find the best fitting degree 3, degree 4, degree 5, degree 6. And eventually, this baby right here will approach that one. We will turn cosine, as promised, into a polynomial. Okay? It's easy. We've got the magical formula here for all the coefficients. Alright, let's get to work. Talk is cheap. So how do we find the first one? Well, according to our recipe here, what was our recipe here? Our recipe said that to find a naught, the first coefficient, all I got to do is figure out f of the point. In this case, we're doing 0. So in this case, I got to do cosine of 0. Well, cosine is super easy. Cosine of 0 is equal to 1. Done. That tells me that this guy right here is equal to 1. Yippee-ki-yay, I've got my constant. Well, the first one anyways. I only have infinite many more to go. No big deal. Alright, that gets us there. Then you say, well, okay, I've got the flat line now. Can I get the best fitting tangent line there? To do that, you need to figure out A1, and you need to figure out the best degree 1 polynomial that fits there. Lucky, you might wonder, how am I going to find A1? I can't find A1. We've got a formula right here for A1. It's so easy, I'm telling you. This is the key right here. We're going to find A1 by following the recipe here. A1 is equal to the first derivative at 0. Okay? Divided by 1 factorial if you want, but 1 factorial is 1 anyways. So, first derivative, what's the first derivative? The first derivative would be, let me think. I should find my derivatives here on the side. I will do them here, my derivatives. So I know f of x is equal to cosine x. Yes, f prime of x would be equal to negative sine of x. So my first derivative at 0, that's given me negative sine of 0, which is equal to 0. So therefore A1 is 0, and now I've got my first polynomial. This guy right here is equal to, let me change to the other writing here. This one right here is equal to, my degree 1 polynomial is equal to 1, I'm copying it from here, plus 0 times x. That right there is my first polynomial. Got it? It matches the value and it matches the first derivative. We're good so far up to that. Right? A1 is equal to 0. Once we're good up there, we need to continue and find the best fitting degree 2, the parabola. So to do that, we move on and say, okay, how are we going to do that? So we had, I'll write it again because that was so fun. We had that f of x is equal to cosine of x. We had that f prime of x is equal to negative sine of x. And now I need f double prime of x. F double prime of x would be negative cosine of x. And I need that because, according to my excellent formula, a2 would be equal to my second derivative, evaluated at 0, and then divided by 2 factorial. So my second derivative is negative cosine, so this would be negative cosine of 0 divided by 2 factorial. That's clearly negative 1 over 2 factorial. Yippee-ki-yay. That gets me this far right here. So this tells me that this one right here, I'll change back to writing on the actual paper here. This tells me that P2 is equal to, I already had A naught. A naught was equal to 1 plus, I already had this one. This one was equal to 0 x's. And now I've just got this one. This one is equal to negative 1 over 2 factorial x squared. So this, my friends, this right here is the formula for this best fitting parabola there. Nice, huh? But wait, there's more. After we've got the best fitting parabola, degree 2, what do you think we want? We want the best fitting degree 3 polynomial. So for that, we need to find A3. And you may wonder, how in the world are we going to find A3? How do I find the coefficients? Right here is the key. We've got everything that we need to know about coefficients right here. This amazing formula that tells you all the coefficients. A3 would be the third derivative evaluated at 0 divided by 3 factorial. Duh. So I need to find more derivatives here because I need a third one now. Let's see. I'm not afraid. F triple prime of x is equal to, I need the derivative of that. That would be a sine x. So therefore A3 would be equal to, according to my recipe, it's my third derivative evaluated at 0 divided by 3 factorial. I reckon that would be sine of 0 divided by 3 factorial, which of course would be 0 because sine of 0 is 0. So therefore, switch back to this one. Let's do it. The degree 3 one is actually equal to the same as a degree 2 because this part is 0. So therefore, this one is also equal to P3. P3 is equal to, let's go through it, 1 plus 0 x plus negative 1 over 2 factorial x squared plus 0 x thirds. So now we need to move on to the fourth approximation. That's that one right there. That's P4. To find P4, I need to find A4. So I need to figure out the fourth coefficient. It's all about the coefficients. Once you've got the coefficients, you've got everything. So to find the fourth coefficient, we go like this. I'm going to need a fourth derivative here. So I need the fourth derivative of x. That would be the derivative of the third derivative. That would be cosine of x. And my amazing formula tells me that the fourth coefficient is equal to the fourth derivative evaluated at 0 divided by 4 factorial. That would be equal to cosine of 0 divided by 4 factorial. And of course cosine of 0 is equal to 1, so that would be 1 over 4 factorial. So this guy right here, A4, becomes 1 over 4 factorial. That's amazing. That means I've got the exact formula for this guy right here. The exact formula for this one is P4 is equal to A naught, which I had already found was 1, plus 0 x plus negative 1 over 2 factorial x squared plus 0 x to the third plus 1/4 factorial x to the fourth, and so on and so forth. Now let's pause for a second. Take it easy. Take it easy. What have we been doing? Put the pen down, relax. So, we're doing something amazing here. We're constructing cosine out of the coefficients. And in doing so, we're coming up with something that looks like this. It looks something like this. We're getting that the cosine of x is equal to 1. Skip the zeros, by the way. All the odd ones will be 0. Minus 1 over 2 factorial x squared plus 1 over 4 factorial x to the fourth. After a while, you don't have to do 1,000 of these to see what the pattern should be. Pattern might be, the next one might be negative 1 over 6 factorial x to the sixth plus 1 over 8 factorial x to the 8th minus 1 over 10 factorial x to the 10th, and so on and so forth. ladies and gentlemen, I present to you the bridge for cosine. That's a polynomial, not a polynomial. Well, up until today, you always thought cosine was just cosine, but now you see it in a totally different way. It is actually connected to a famous polynomial. Amazing. So back on your on the promise that we made at the beginning, can we find this bridge between these two crazy worlds? And the answer, of course, is an affirmative and a triumphant yes. The cosine is a 1 minus 1 over 2 factorial x squared plus 1 over 4 factorial x to the 4th minus 1 over 6 factorial x to the 6th, and on and on and on. Duh. See why they pay me? Do you see why they pay me? Amazing stuff. Alright, I think that'll do it for one day. You shouldn't watch any more videos for one day. Take the rest of the day off. We'll see you guys here next time. Peace.